just a little disclaimer here. Some of you might wonder why there is Michael Ploed standing there and not Chris Richardson. Chris had to cancel his talk because he had to call in sick, and Peter and Jay, the organizers of the conference, came up to me and asked me if I couldn't step in with him on the same / similar topic. And since I do quite a few talks on event sourcing and CQRS, I already had a slide deck, and I'm filling in Chris now. Please bear with me, the slide deck isn't 100% compliant with the slide masters that you usually see at the Spring One conference. That's the reason for that is the limited time, but I think the content is more important than any template. And yeah, let's kick off with the topic. And let's start off with a review of a classical, I would call it old school N-tier software architecture. What we see here is something everybody of you has learned in university. Everybody has seen that throughout her or his career many, many times, and there shouldn't be a lot of surprises to anybody in this room right there. So usually we have some client, we have some SOAP or REST endpoints, we have some business logic and some data access, and with these things come also different kinds of models. And the characteristics of this kind of architecture might seem, I would say, extremely obvious at a first glance. So the first characteristic is we read and write data through the same stack of architectural elements. So we read and write basically through the same layers, like we go through the business service down to the data access logic, the repositories, and whatnot. And the same is happening for the right part there. The second characteristic is we use the same data model for business logic processing, for reading data, and for writing data. Might seem very obvious and a no-brainer at a first look to the topic, but as we will see later, we might find out that there's scenarios where this might not be the best choice that you can have. The third characteristic is the deployment units. Usually I would say we at least deploy one var or EAR file to some Tomcat application server, or we have a Spring Boot application that contains the web part and some business logic and some persistence logic. And then we, of course, have the same, we run down on the same data store. And if we change data, we usually go ahead, especially well, what means usually, especially with relational storages, we change data sets directly. So if I update this row with ID 1 right there to another value, the data set gets updated directly. Of course, the database in its core or in its basic runtime holds something like a transaction log or something like that. But basically, from the viewpoint of an application, the old value is gone after the transaction has committed. Well, we could easily say, we've done that all the time. Throughout history of IT, we have been very successful and very productive with this kind of approach. Yes, that's true. And there are many, many applications that work really well with this approach. And not just applications, but also teams that are used to that approach and that can write decent and good software with this approach. Please don't get the impression that I'm going to tell you in this talk that everything we've done in the past is crap. That's not the case. We had very good reasons for doing things the way we've been doing them. But there might be some drawbacks to that kind of architecture that might, I would say, quite a few cases, be more suitable for an alternative solution. Let's take a look at these drawbacks. One is basically the data model that we have is a compromise, because we compromise on business logic processing, reading, and writing data. Let's take the reading stuff as an example. Many applications rely on database views. Those might also be persistent views in order to improve read performance against the data storage. So they actually have a pseudo model for the read side already. But in the end, we use the same domain models, we use the same storage for reading and writing this data. And in this setting, we can't scale read and write independently because we deploy these things together on the same software architecture stack. So if we have an application that has what's, let's say, a 90% read part in terms of throughput, calls, CPU time, memory usage, or whatnot, and a 10% write part, we couldn't go ahead and scale out the read part on a significant scale and have a rather scaled down write part. If we want to scale our application with this kind of approach, we would have to do it on the whole stack. So the deployment unit contains read and write code. Both of them run through the same layers of data. And we have to scale out both parts in parallel, even if it's unnecessary. Another thing that many applications solve on their own through additional functionality, through additional libraries, and so on, through triggers in the database, is that in the essence, this approach doesn't contain any historic data. When I perform an update on a relational table, I just can read the new value. The old value is gone from the viewpoint of the application. So I can't just go ahead and roll back my application to a state where I say, please give me the data state of last triple witching Friday in the banking business, for instance, or give me the data state of tomorrow 6 p.m. or something like that. I can't do that. And if I want to do that in this approach, I have to take care of it. I have to write code that gives me these features and these opportunities. And this approach tends to create huge monoliths. I mean, obviously, we deploy these things together. We have very coarse-grained deployment units, and we try to merge things together as much as possible. And usually we start off with a, let's say, tiny, nice example project, the typical Spring Boot Kickstarter, and after, let's say, 2 or 3 years of project craziness, we end up with a monolithic mess, usually in these kinds of architectures, unless you really take a lot of architectural care. And one approach that addresses these kinds of challenges is the approach of event sourcing. Event sourcing is actually nothing new. And it isn't something that I have invented, to be honest. I'm far from that. I'm just talking about it. Event sourcing is a pattern, an architectural pattern, that represents the state of the application as a series of events. So we just don't have like one state stored in a relational storage. Usually we have the state being computed by certain events. And this might sound awkward in a first position or when you take a first look at this. A lot of questions are asked. How about performance? How can we query this event? We will all address these things. But let's take a little break and really think into many business domains, how they are structured from a really business domain perspective. For instance, a classic example is tracking of letters and packages being sent through some logistics provider. I mean, what's the life cycle of this package being sent? It has been ordered for a pickup at some location. it got picked up by the driver of the logistics company. It has been sent to some sort facility. It has been sorted, it has been dispatched to another location. It has been added to another sort facility. It has been put on another car, and it has been delivered to the customer. And of course, we could go ahead and model this in the classic architectural approach. But if you really think deep into the business domain and in the nature of this business domain, these are actually all events. These are things that happened in the past. And so this model might be ways more natural to many business domains if you really clearly think about the business domain itself. And the typical building blocks of a software architecture or an application that relies on event sourcing are, we have some applications or one application. Then we have an event queue, and we put events on this event queue. This event queue stores the events in a event storage, and then we have some event handler logic that is doing stuff with these events. It might validate some events. It might process these events further, and so on and so forth. And the sequence of events that is being passed through the event queue to the event storage is also called the event stream. So we have a constant stream of events from our application into these, I would say, event sourcing building blocks here. And what is, let's take an easy example. The example is an incident management system. We have an incident created event. So our application, the user clicks in the bug tracker, create new incident, or in some other incident management system, and says, hey, my mouse is broken. It doesn't work anymore. So we could model that as an incident created event. So there has an incident has been created. In the classical architecture, this would usually be an insert into incident with values, blah, 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 and so on. After that, we change the text of the incident. So it is allowed to alter, for instance, the description of an incident, whereas it wouldn't be allowed to alter the reporting user, for instance. So we fire off an incident text change event and say, okay, it's especially the left button of the mouse that had been broken. And then we resolve the incident or close the incident by a solution that the mouse has been replaced to the user. And this is a typical, a very, very easy example of an event stream that is happening. If we would model that in the classical architecture, we would have an insert statement for the incident created event. Then we would have some update SQL statement that updates the text. And then another update statement that changes the status and adds some solution to the incident, for instance. Easily speaking. What is very important here is that an event is something that happened in the past. It is not something that will happen in the future. And that is very important here, because when we think about naming of these events, it is a common best practice in event sourcing blogs, literature, and other talks on event sourcing, that the events are something that happened in the past. So we formulate the names of our events in past tense, and the names of the events should be very expressive. And I am personally a huge fan of the domain-driven design book and the principles behind domain-driven design. And you will see these letters, DDD, that stand for domain-driven design, various times throughout this talk. Because in my eyes, the names of events must be a part of the ubiquitous language of the project. So you should take great care about how you want to name your events. Some good examples is, for instance, a shipment delivered event. Another good name is customer verified event, or cart checked out event, if we talk about an online shop, for instance. So if we take a look at these events names, we instantly kind of know what has happened here. And you see we have delivered, verified, checked out, so past tense. Bad names for events would be, for instance, create customer event. Create customer is a command-style syntax. And the command usually processes the data and then issues the event. So after I would say the business logic has been processed, the customer has been created. Another bad example is will save item event. Why will you save the item? Haven't you saved the item? Is there something that's still happening until some item has been saved? And the worst case of all is the do stuff event. I mean, we can build a complete system with just this event. And I mean, nobody knows what's going to happen there. Is the event going to order beer for me, or is the event going to ship something to a customer or whatnot? So please take great care in how you name these events. Let's take a look at a very easy code example, how such an event could look like. We could have an event ID, which is usually modeled as a GUID or something like that. We must have an event date when the event has happened in order to recreate a sequence of events, obviously. And this date should be on a timestamp basis with the most precise timestamp that we have available in our programming language or in our system. And then we, for instance, add a customer number and some comment, I would say, business payload to the event. A very interesting question is how fine-grained we should model our events. Because in usual systems with a usual complexity, we find ourselves having a lot and many entities. So let's say 400, 500 entities. Would we really want to go ahead and have events that are grained on an entity level, what has happened to an entity in a business domain? I wouldn't do that, because usually when you take a closer look, these events do have some, I would say, some CRUD type of character to them. Most of the time, and that is also, again, a domain-driven design pattern, events are usually happening on the basis of aggregates. Aggregates in domain-driven design are a collection of, I would say, entities that are bounded to a specific business context. And you usually have one root, or you must have one root entity. And this root entity is responsible for the life cycle of the whole object graph under it. For instance, a credit application, I apply for a mortgage loan. For instance, I want to buy a house. So I have the mortgage loan application as the root entity. And behind that, I have, for instance, some income information, how much money I earn, from which sources I get my money, how much money I spent on, for instance, other credits, or how many credit cards do I have, and do I still have to pay off rent or another house, and so on. And these other entities or these other value objects, they are irrelevant if we want to remove the mortgage loan application, because they heavily depend on that application. And so you can actually go ahead and wrap these entities up into an aggregate, which is a logical construct, you might say, and apply the business logic on this part of the system. And what this usually gives us is, I would say, rich and very expressive event model system that we have. Because we're not too fine-grained, we have some higher level of abstraction, and this abstraction is usually bounded to a specific business context. For instance, mortgage loan application or customer management and whatnot. It is very important that you always treat these events immutable. So after you have fired off an event, you do not change the event. Never. The only thing where I would say, okay, you might change something is if you add, I would say, some infrastructure processing data. So when has the event been processed by the event queue or something like that. But you never change any business data. And basically, I would go ahead with the rule, you never change data. And this also applies to the deletion of events. We never delete an event from the event store. Never. A delete operation is just another event here. So we create the incident, we change the incident with the text, and after that, we remove the incident, or we mark the incident as removed. However, there may be one exception where you will be forced to deleting data, and that is when regulatory requirements step in. I'm based out of Germany, and Germany has very, very strict data protection rules. So, for instance, if Facebook would be based in Germany, Facebook would be illegal, and they basically go to jail, according to German laws. What they do with the data, and that applies to Twitter and whatnot. And so there might be the case where you really have to delete customer data out of these events. I've been working on an event-sourced system, and we discussed that requirement very heavily. And we basically discussed two options. Do we delete the events for the customer data? Or do we just anonymize the customer data? We decided for the anonymization of the customer data. So we had the events where we just blanked out first name, last name, addresses, and so on, so that after a certain time, you couldn't see this data anymore, and we were compliant with the law. But law or regulatory compliance is the only reason where you might consider playing around with the events in the event store after they've been stored there. Usually, this event bus or the event queue is implemented by a message broker architecture. And most of the time, what I see in many projects, I'm working as a consultant for software architectures and stuff like that. And what I see in a lot of projects is that they start off with an existing system. I mean, who starts off greenfield projects? These happen, but they are a rarity in our industry. Usually we have to deal with some kind of legacy code and something. So for instance, we've been playing around with service-oriented architectures for ages. We bought a high-priced enterprise service bus, so our manager might come ahead and say, hey, that's awesome. Let's reuse the enterprise service bus from the failed SOA project for that. It has a ton of features. No, don't do that. Really don't do that. And hell no, don't do that. Because what I would actually prefer are dump pipes and smart endpoints as a suitable event sourcing architecture. So just use lightweight message brokers. There's great things, ActiveMQ, RabbitMQ, and so on. These are lightweight message brokers, and they are built for scale. They are built for easy integration and easy operation. Don't use these monstrous enterprise service buses that lock you into infrastructure, that lock you into, let's say, some enterprise tooling which has the label, it isn't meant to be fun, it has to hurt in order to work. Don't do that. I'm not dissing specific companies here, but I think you got me. And the advantage when we follow this principle of event sourcing is that we instantly have the ability to rebuild certain states of the application. We get that for free. Obviously, there is no currently event sourcing tool suite and something like that. So event sourcing, the same goes out to microservices and so on. is no free lunch. You have to do a little bit more and a little bit more of thinking and a little bit more of ramping up a working infrastructure than just going ahead and deploy a Tomcat server and put your WAR files in there. You have to do a little more. But after you've done that, you get the ability to rebuild a certain set of data to a certain specific time instantly. Think about bigger projects in enterprises. How often haven't you been in meetings that discussed which data set do we need for the business test now? On which environment is that data? How can we load it over there? If we have event source systems, we just go ahead and say, okay, we want the end of the first quarter data. So we just do a rebuild of the data of all the events, and we're there. We have it. You can also go ahead and have temporal queries. That means I can query where, or for instance, how the customer aggregate has looked like on February the 15th in 2014 at 12 o'clock, if I want to do that. That is very interesting for meeting audit requirements. That's something that your data audit loves when you say, okay, no problem, we have the event store. We can tell you exactly what has happened when with this piece of data. And you can have an event replay, which is very interesting for various reasons. And the most interesting thing is actually debugging or finding really nasty business logic bugs, because you can go ahead and rebuild your data set to a specific time before some reported bug by a user has happened. And after that, you can replay event by event and see where the bug has happened. And then you can go ahead and step into a specific piece of code. In the classical architecture, we would be stuck with a relational storage, which is at a data set that is after the bug has happened, for instance. And we now have a hard time to replay the game and the business logic in our minds. With an event-sourced architecture, we go ahead and replay the data set until the bug has happened, and then replay event by event. That is very convenient. Well-known examples for event-sourced architectures are, for instance, version control systems. So if you take a look at Subversion or Git and so on, you instantly see this event character, because you can have a replay on commit by commit basis to a Git repository or Subversion or any other version control system that you use. And in the relational world, we also have this characteristic in database transaction logs. If you look at how a relational database works in its internals, you will see that the transaction log consists of a series of events in most relational storage. So what is very obvious is that the event store has a very high business value, not just because of the features that I just mentioned, but also because when you get a deeper insight in your business domain, and you get you discover newer analytics on your business domain, on the behavior of your business domain, you can apply these analytics to older data. Imagine you guys having an online store, and you play around with some AdWords campaigns. You do advertising on Instagram now, and on Twitter, and on Facebook, and on Google, and whatnot. And you get an insight on the analytics on how users behave based on these ads. With a classical architecture, you can just apply these analytics to the current state of the application. Now, if you get new insights on how these analytics might work, you can apply them to the past as well and verify your assumptions. So this is a very, very high value. But, of course, we might ask, if we just stick to this model that I have just displayed right now, don't we run into performance problems if we, for instance, do temporary queries against the event store? Yes, of course. I mean, the performance of a system that I have displayed until now will be horrible, because we have to, for every query, so far, replay every event in order to get the current state of the application, which is, I mean, without a doubt, a very bad idea. But the idea goes a little bit further, because what we can do is we can derive a application state, for instance, the current state of the application, from the event storage through some event handler logic. But we can also work with two application states. For instance, we can work with an application state of the previous day, of the previous week, and of today. And we could query both application states, because we can easily derive these application states based on the event storage. And a way to deal with these things, to create this, I would say, pre-processed application state, is the CQRS pattern. CQRS stands for Command Query Responsibility Separation. What does this mean? Here, we're now talking about taking a closer look at the read and the write characteristics of our application. Some of you might have wondered why I stressed out this read and write behavior of the classical architectural approach to applications in the beginning, in the intro of my talk. The reason is exactly this, because commands in the context of the CQRS pattern are write operations. Yes? I'll come to that later. The question was if the event store can be an RDBMS. I'll address these things later on. I'll just work on completing the overall picture. And then later on, I will go ahead and also discuss some challenges that arise from these kinds of applications. And one of these things is obviously going to be a discussion what technologies are sufficient or good choices or transactions and stuff like that. I'll come to that, I would say, within 20 to 30 minutes or something like that. Commands are write operations. And queries are obviously read operations. So there's no big surprise to that. And responsibility separations is that we go ahead and separate our read and our write operations. If we now go ahead and revive our classical old school architecture and apply CQRS to it, the first step is rather easy. We take an AX and split the application in half in a first step. So we split up the query part and the write part of our application. And that is also if you have an existing application and if you have a certain business domain that might be suitable for this approach. This would also be your first refactoring step towards, I would say, event sourcing and CQRS. You just separate the logics that read stuff and that write stuff, and you obviously will have to rewrite some code for queries on the write part, for instance, for business validation, cross-field validations, and stuff like that. So the basic idea is really simple. If we take a look at an easy code example written in Java, we have a typical, let's say, service interface with a save incident, a update incident method, a retrieve by severity method, and a retrieve by ID method. The first step towards a CQRSification of this interface is splitting it up into a query service and command service, which then have the read operations and the write operations. And the issue, let me go back to this slide here. The issue that we still have is both of these, in this current state that I just displayed, is we are running against the same data storage, basically. So and the idea behind this slide is also we are working with the same model right there. So, so far, in this current state, we don't get a lot of advantages. And I would say this current state of the architecture, of the refactoring process is, I would say, quite insufficient. Because we just add complexity without gaining substantial advantages. So we shouldn't end there. Because what I would say, really good combination of CQRS and event sourcing looks like is a system that looks like this. What we do here is we go ahead and let's start with the command part on the right side from your viewing direction. This command part is going to issue events. And here comes the event sourcing idea into play. We issue events to an event store from the command part, from some data access logic, or you can also fire off commands directly to the event store, or fire off commands that fire off events to the direct store, to the event store. And on the event store, on this queue, we also have an event handler listening to it. And what this event handler then does is it is able to create and to derive the application state into a separated read storage. And the read storage can be, for instance, a relational database. But usually, in most applications, you wouldn't have a relational storage for the read store. You would, for instance, work with some in-memory data grids, for instance, like Terracotta or Hazelcast or something. Or if you have a very graph-oriented business domain, you might, for instance, choose Neo4j as your read storage because it fits the nature of your queries very well. And the read part in this architecture always queries the read storage. So we never query the event store from the read part here. And a substantial advantage that we get there is we don't have to reuse the model, the event model from the write part in the read storage. We can have a highly optimized structure that suits our queries very well and that makes the queries go really fast on the read storage. For instance, I've worked on a project where we had, for instance, for one aggregate, 15 representations in the read storage that were highly optimized for certain queries. Because these would be queries that would be very complex, very long running, that crunch a lot of data. So we already pre-aggregated data for these queries in the read storage. And what we get from there is we can now individually scale and deploy these things. And this is the part where, for instance, a microservice architecture might come into play. So we might have read microservices and write microservices in this architectural stack. And we could scale these out totally independently. If we have a lot of read stuff to do, we scale out the read microservices on a larger scale than the write microservices. Or if we, for instance, go ahead and know that due to some end-of-the-day processing in our business domain, we need to have more, I would say, write capability in our system because at the end of the day processing, we write more data than during the day. We scale out the write instances in, let's say, Cloud Foundry or AWS or something for 2 hours, and after that, we scale them down again. So we have a very individual and a very powerful means to scale and deploy our application with this. In addition to that, we have a high degree of freedom of choice depending on our technologies. We could, for instance, go ahead and have a, let's say, if we have a very complex business domain on the write part, we could go ahead and write that with Scala or Clojure or whatnot. Whereas on the read part, we usually fire off some queries So we go ahead and do that with Grails, for instance, or with Groovy, or with plain Java, or something like that. But don't get me wrong, I don't encourage I always call it technology zoo in organizations. Make wise decisions which technologies you want to use, and give I would say, a thought-out tool set that, on the one hand, gives a certain freedom of choice, but on the other hand, also has I would say, management of technologies that we have. Because if we don't limit these things, and in the beginning, we end up having, let's say, 50 technologies after 2 years. And obviously, I know us developers, we love working with different technologies. It's great, but from a, let's say, CTO, CIO perspective, it's going to be a pain in the long run. So give some freedom of choice, give some options, but think these out very well. And this kind of architecture also fits very well into the idea of the bounded context from domain-driven design. Because we can go ahead and define business contexts for these microservices. These contexts can be bound on an aggregate level, but a bounded context might also include 4 or 5 data aggregates. And this fits very well. And if you take a close look at best practices in microservice granularity, I mean, there is a lot of discussion going on in the community. I mean, there's the idea of nano services. Then there's people saying a microservice shouldn't have more than 200 lines of code. I frankly disagree with that, to be honest, my personal opinion. I think you should bind, and that's something you always read in many sources and you hear in many discussions, bind your microservice granularity on the bounded context of your business domain. Always let the business domain drive your software architecture, not technology. So these things, event sourcing, CQRS, and I would say microservices in the broader field are very interesting architectural options. But there was the one question that asked, what about the RDBMS? Can we have the RDBMS as a event store? Could we use an RDBMS as a read store as well? What about caching? What about consistency in this architecture? We haven't discussed consistency at all so far. What about validation? Where do we validate data? I mean, the question about the validation, where we validate, is quite easy when we validate data that is in our aggregate, where we build our events upon, because we usually have the whole data available at the command level. But you also might have validations that include other aggregates, that might include even other business domains. So there's some complex validation logic out there. And what about parallel updates, parallel processing of events, and so on and so forth? And I will go, yes?
Yeah, I was going to ask about, how about the representational language of the events?
Okay,
Yeah.
the question was, okay, I will go into that right now before we dig into the other stuff. The question was, how about the representational language of events? You have basically any freedom of choice. An event can be a serialized Java object in the worst case, I would say. I usually tend to represent my events as JSON strings or XML stuff. So data formats that can be easily processed and stored by various storages. But you can also represent your event, for instance, as a table in a relational storage. So you have a lot of freedom of choice. But I personally tend towards representations that are very flexible in terms of technologies and logic that consumes them. So my default choice of representation is usually JSON, I have to say. Yes?
Any chance of
Yes. The question is there a chance of redundancy, read and writes? That is exactly point one, what I'll discuss right now. So in terms of consistency, yes. The answer to your question is yes. Systems based on CQRS and event sourcing are mostly eventually consistent. I would actually go this far and say nearly any distributed system in the world is, to a certain degree, eventually consistent. So there is hardly a full consistency in distributed systems. And the eventual consistency, it can happen, for instance, storing to the event store. So if you do an asynchronous store to the event store, you might be able to open a transaction against the queue, and the queue might give you some sort of degree of guarantee that you get stored into the event store. But if you just go ahead and do a fire and forget, you don't have any guarantee that the event ends up in the event store. So there is a consistency risk on this end. There might also be a consistency risk on the event handler's end. For instance, if we don't update the read storage immediately, if we go ahead and say, okay, we do these processing of the events against the read store every minute or every 5 minutes or something like that. So you might run into a risk right there as well. Or you might run into a risk with updates against the read storage. How transactional are these updates? Are these updates actually a part of the issuing of the event against the event store? Usually not. So you have a consistency risk as well. And depending on the technology that you use on the read store, you might again run into consistency issues here. For instance, if you use a highly distributed in-memory data grid, well, what tells you how consistent the updates to other nodes are? If you read the blog, Call Me Maybe, has anybody ever heard about that blog? Yeah? This is a very, very interesting blog that sometimes makes you shrug when you read that, depending technologies that you use. This blog especially deals with consistency and replication, partition status, and so on. And there is, in terms of consistency, the CAP theorem that says you can even have consistency, availability, and partition tolerance, but you can only have 2 of them. So you exactly have to choose which way you want. So if you favor availability, obviously you want to have some sort of partition tolerance. So the choice is, do you want availability or consistency? If you favor consistency, you might go ahead and do some adjustments to that system that drive you to a very consistent approach. If you favor availability, you have a lot of freedoms of choice how much you want to limit your consistent guarantee in the system. And that is something, and the next slide might be a little bit shocking or something like that to, I would say, CQRS and event sourcing purists. If you really want to, and I would then, if you really want that, consider if event sourcing is a suitable architectural choice for your system. You could go ahead and build a, well, fully is a little bit exaggerated, a very consistent system which follows event sourcing principles. And there comes your relational storage in place. We could go ahead and place the event store and the read storage in a relational database on the same node. And we could add the updates and the inserts to the event storage and the read storage in one transaction. And there we would have the idea of the event system with the events on the event storage, the idea of the read storage system with a, I would say, very high transactional guarantee. Would this system scale very well? No, it won't. And that's the point that I want to stress. This approach here with the like very good. I should actually call that slice very good consistency. This system here will be quite consistent, but will it be a very good option for scaling out and for availability? No, it won't. But you can also, you should consider your business domain. What level of consistency you really need. Don't do eventual consistency just because you read it on Twitter or in some blogs around the corner like every 5 minutes nowadays. No. Inspect your business domain and the business requirements, the regulatory requirements that you have, and also the business value of failed transactions. Do they really hurt you? How much money costs that to my organization? In order to derive a suitable level of consistency for your business domain. And what can be done, for instance, is that you go ahead and do the insert into the event store, extremely transactional. So that you add a lot of, that you add a transaction to this insert, then you know, okay, this part is, I would say, quite consistent here. But on the read storage, okay, we do this update asynchronously, and we can live with data that is, let's say, deprecated for 5 to 10 to 20 minutes. It depends on the data that you have. For instance, a classic example to this is the country list. I mean, I would say it is a very rare occasion that a country changes its name, that a new country arises, or that a country disappears. So if we update, for instance, these kinds of data, like every 6 hours, which is an eternity in terms of application server and application lifecycle, we're totally fine off. But can we live with updates on the read storage with a, let's say, 5-minute guarantee on a stock trading system? Probably not. That might be quite difficult, actually. So what I want to say is there is no standard solution to that topic. You really have to inspect your business domain, and you really should be aware of the options that you have. Going back to technology choices, yes, you can use the relational storage. Is it a perfect choice for storing events? I don't think so. Is it a good way for the read storage? Maybe. But there might be other options like a graph database or a in-memory data grid with distributed maps that the queries are basically key lookups to maps, for instance. Might be a choice. You have to inspect your business domain and let your business domain drive these decisions, not the fanciness of some technology. So far, we have now discussed the point of consistency. Let's talk about validation. Validation is a very interesting thing. It might seem, I would say, quite obvious at a first glance, because validation tends to be easy. Okay, I have my not null fields, and then one field should be a credit card number or a completely filled out address, and there is min and max validations. I mean, these are the easy validations. You can easily deal with them in the business logic, or even when entering into a REST call or something like that. Those are the easy things. The more interesting things are uniqueness validations. For instance, let's take a look at this example domain here. So we have a user which has an email and a password, and we split this up into 2 commands: a register user command, or register user command, change email command, and after these commands have been processed, they fire off user registered event and email changed event. And here you see a very nice example for the naming of these things. The commands are present tense. Register the user, change the email. After the command has been processed, the user has been registered and the email has been changed. So we can register a user and we can change the email. And now we have the requirement that we need to process more than 2 million user registrations per day, and a user can change her email address. However, the email address must be unique. Now, if we think again in our, I would say, event-sourced system, which I would say validation risks do we have? So upon registering the user, we need to do a query against the read storage on, for instance, a list of distinct email addresses. We have one data bucket, registered email addresses. Is the email that the user is coming along with already registered? If yes, the user has to choose another email address or has to reactivate her account, for instance. If no, everything is fine, we insert. And the same validation takes place when we want to change the email address. Is the new email address unique in the system? So the risk that we might run into with this transaction is that the update to the read storage hasn't occurred yet. For instance, another user has used, for instance, my email address, michael.ploed@inoq.com, in order to register illegally, and the read storage says, no, this email address doesn't exist yet. So we can create, or we can store this event, user-created event, in the event storage. And now we have an inconsistency in our event storage, because there's, at the current time in the event store, 2 users with the same email address. And if we talk about, I would say, this scenario with business people, we often, and I would say often means 95%, get the answer, oh, this must not happen under any circumstances, and please take huge technical measures in order to prevent this from happening. But I always, of course, we can do big technical steps in order to prevent these things from happening by increasing the consistency level in the overall architecture, but also sacrificing availability. And if we go ahead with the availability argument to the business things, to the business managers and to our manager, we often get the answer, oh yeah, you have to take care of availability as well. But let's take a step back. How high is the probability that this validation will fail? Does this happen very often? I would say in this use case, yeah, it might happen sometime, but is it the regular case that this is happening? I doubt that. I don't think it's going to happen very often. Let's say we have a 0.05% that this happens. Then you should take into account which data do I need in order to do this validation, and where and how is this data being stored. Maybe we can mitigate the probability by quicker updates to the read storage if we have a, I would say, high business criticality on these things. But the end of the story is basically, what is the true business impact of a failure in this validation process? Does this cost us a lot of money? Do we really need to deal with these things on a technical basis? I mean, the user, duplicate user thing, how can we deal with this? Okay, there is the event in the event store. We now have 2 users with the same email address in our event storage. But couldn't we just go ahead in the event handler when we create this distinct list of email addresses? We will find out the error pretty quickly. Couldn't this event handler then just issue another event to some customer service representative that emails the user and says, hey, we have a hiccup in the data, sorry, please change your email address with this link again. And we're fine. Easy solution, organizational solution. We could also have a compensation event that just rolls back the email changed event to the old email address. And then we just send the user an email and tell him, hey, something went wrong in processing your email address change. Please try again. fair enough solution for many of these things. So always, again, the business domain is the main driver for the consistency level in the system. Another thought that we can apply to this topic is, against what would we want to validate? One option is, and please don't shrug, I have a second slide right after that one. We could validate from the event store. Usually the event store is more up-to-date and more consistent than the read store. We could validate from the read store, which I would actually favor. Or we could have some added validation in the event handler. I would actually favor, strongly favor, and that should be your 98% choice. Validate from the read storage. And just have some, I would say, what I always call them in the read storage validation buckets that get updated depending on the business criticality of this kind of business operation. And you usually are pretty good off with that one. What I would never do is validate from the event store, because you will run into performance problems with that over the long run. Especially in high volume systems, high transaction systems, you will kill yourself in terms of performance. So far we have talked about consistency and validation. Now let's talk about parallel updates. Again, we're going to deal in our business domain. You know, the user with the email and the password, register user command, change email command, and then the two events. But what happens when Alice and Bob share an account and both update the email address at the same time? So, scenario, Alice and Bob are having a divorce, and Alice tries to change the account to her email address. Bob tries to change the email account, the account to his address. What's going to happen? The first thing that we might to take a look at, how is this issue being dealt with in, I would say, the classical old school architecture? What we could do there in the database, we could have pessimistic or optimistic locking on these data sets. So with pessimistic locking, we usually issue the classical select for update command. Have fun on scalability with that one. On the data set is locked for that transaction. We change the command and so on and so forth. Or we can use a version incrementation or timestamp mechanism with optimistic locking so that we increase the version with every update. And when something goes wrong, we get a, let's say, in typical Hibernate terms, optimistic locking exception or something like that. Again, the locking quality should be driven from our business domain, what we really need. And a pessimistic locking on a data level will obviously very hardly work on an event sourcing architecture. What do we pessimistically want to lock? The event queue? The read storage? It won't work. So that won't work. And let me be very clear, in my eyes, and I think that is also the strong opinion of the overall community that we're living in, is pessimistic locking is a bad practice. You usually don't do pessimistic locks, even in the classical systems. Obviously, sometimes on update operations, you have some optimistic locks, but if you take a look at patterns like transactional right behind or stuff like that, where you try to put the DML, data manipulation language statements, as far as possible to the end of the transaction, we try to minimize pessimistic lock contention in our databases. If we want to pessimistically lock something in an event-sourced architecture with CQRS, we could actually go ahead and issue a user-locked event to the event store. which gets replicated very fast to the read store, to a bucket, is the user locked? Can the user be worked with? And we can do that, for instance. But as a business rule, for instance, if I implement a mortgage loan system, and there is the credit decision, and the directors of the bank approve or disapprove your credit application, the director might go ahead and do a business log and take this application into a in-work status. That's what usually happens in these kinds of systems. So if another director wants to go ahead and take this application in work, they can't because there's some business logic that prevents them from doing that. So that is something, I wouldn't call that a pessimistic log, because a pessimistic log is always on a row level. For me, that is a business log. And business logs might work very well in these kinds of applications. But do we really need these logs? Really question that. And if you think about classical old school, classic architectured systems, they are usually running very well with optimistic logs. So that means if we run pessimistic log, says pessimistic, things will go wrong. With optimistic logging, I say, I guess most of the time things are working very well. And if something goes wrong, well, then I have to do something. Usually it means you detect the collision of the parallel update on the insert, and then you notify the user, sorry, somebody has already changed the data. Please go back, refresh your data, and do your change again. So again, some sort of organizational or operational fix to the issue. So if we want to introduce a optimistic logging approach, we can go ahead and add a version field to our user, and also have the version obviously in the events. In the email changed event. Why not in the user created event? Because this always includes version equals 0. A freshly created user has the version 0 or 1, whichever you prefer. And each writing event then increases the version. So we register, we have version 0 over there. We change the email address, which means we check the version. And this email address changed event should have, for a successful processing, the version that is compliant with the current state of the application. So that means 0, yeah, that's a success, that works. So we have the current version of the user in our hands. Now, the user is basically in version 1. We issue another event, which encompasses version 1. That's a success, that works. And now, suddenly, we come along again with the email changed event, but on the user in version 1. That means that is the parallel update from Alice and Bob that we see there. And this, obviously, will be detected when we update our read store, because, again, here, we are not fully consistent. We don't validate against our event store. We validate against the read store, and then we just raise another event, email change failed event. And this event might trigger an email being sent to the user, hey, sorry, we detected that something went wrong with your email change. And we're fine. So again, to sum this up, as always, you should be as consistent as your domain requires. And what I think is very nice about these kinds of systems is that they force you in order to think very carefully about your business domain. I've mentioned that quite a few times. It's the business domain that is driving these decisions, not fancy technology or something like that. And you get to think very thoroughly about these business domains when you deal with these kinds of questions. And I found myself, I established some sort of best practice for myself here, because when I started working with these kinds of patterns, I immediately always go back, and when I see a a problem or a challenge, a requirement that arises that needs to be addressed, I usually go ahead and dig into the business domain and derive this decision, the level of consistency, the level of validation quality, the level of locking quality that I need from the real business requirements. And always talk to the business people, what is the cost of things going wrong? If the cost is substantial, we need to do something, of course. We need to address some things. If the cost is not really substantial, if the cost is an automated email being sent to the user and say, hey, try changing your email again, something went wrong, we can live with that. That's fine. Okay. I'm done with the talks so far. I think we have quite some time for questions. Yeah, there's a question here. Wait a minute, I need to come closer to you because I don't hear you. And I'll repeat the question for the audience. So.
I'm just wondering why you specifically decided to do the validation check on the event part.
Okay.
Because usually if you want to have early access, it makes sense to have the command and then fire
Yeah.
the event.
Yeah,
because
okay.
we've not really changed the email already.
Yeah. The question was, why did I do the validation on the event part? I think maybe my slide wasn't very clear about that. I would do the validation in the command against the query storage. But you detect the collision. If your validation says, you can store this user with this email address, and if the query against the read part was stale, with stale data, this will probably be detected when the event handler is running over the events and analyzing the data. And that is then where you handle these things. Yes, another.
In a similar talk yesterday afternoon, we were talking about checkpoints.
Yes.
They're used for the calculation of the read
Yeah.
model.
Yes.
Any comments?
Yeah. The question was, there was in another talk the pattern or the mention of checkpoints as a starting point to updating the read model. Basically, I'm a huge fan of that. I use that very often. Usually, you don't always update the read model from scratch, but you have, let's say, older snapshots upon which you then apply the events on, and these snapshots are obviously the checkpoints that you're going to. Very good pattern. I would call that a best practice. Absolutely. Yes?
Going back to the register user event and
Yes.
validation, if the validation finds that there's a redundant email coming in,
Yes?
you don't know if it's the same user, so at that point, you can't register this user, but we have business cases where they want to know if these registrations fail. You can't apply that to the aggregate because it's not a unique user. What do you do with this event that's failed validation?
Usually, well, it depends on the business domain that you have. If you have an event where you detect later on that the validation failed, I would usually go ahead and raise another event, which then marks this well, I would say this business domain as, hey, there needs to be something done. And from there going on, you can have event handlers that do something with that. One option would be to send out an automated email. So there's then no human interaction required. The user just gets notified something went wrong, please do that again. Or if it's a more complex domain, you could route that domain to a, I would say, service team that is dealing with these kinds of problems and that can then introduce measures that mitigate this situation.
You don't actually create an event aggregate that's for errors. It's going to be an event at that point, correct?
I didn't get you.
You can't save that registered user event into the domain event store because
Yeah.
it's not a user.
Okay, if you detect that beforehand, you don't save the event. You just go back to the user. But if the event has been saved, you would then have to deal with that afterwards. Yes, over there. I'll come back to you later. Okay.
So this has been a very timely discussion. My friend Scott and I have been talking about transactional integrity versus asynchronous.
Yes.
So considering the unique keys problem,
Yeah. It depends. I would say it depends on the database that you use. Of course, yes, if that is the case, and if these things happen very often, you might have a added complexity. But it always depends if this really hurts you. You know, sometimes the database has absolutely no issues with scaling with these kinds of things because things just get written off, and that's no issue. But sometimes you might run into issues, and then you have to rethink how you want to validate and whatnot. Absolutely. Yes?
So if I use Spring Data,
Yeah.
frameworks like that,
Yes.
and if I want to use read-only and command, the CQRS,
Yes.
oftentimes the facility is given to me by all these frameworks will be a little bit lost because now I have to create a read-only
Yes.
repository.
The question was about the usage, for instance, of Spring Data and the facilities that Spring Data offers to us when working with an event source and CQRS environment. I would say it depends. For instance, you can have a great Spring Data project on top of a, let's say, No-SQL read storage, where you can easily use all the query facilities against this read storage. But you just write stuff differently over there. But of course, yes, this goes away from, I would say, the typical Spring Data approach that is pretty much CRUD-centric on a piece of data. So you would basically split things up. You would fire off events, and you would just query through Spring Data, for instance. Okay, another? Yes. Yeah. Yes. Okay. Yeah. Yes. Okay. Okay. The question was if you have a legacy system, and what are the best practices and a recommended way in order to migrate from this classical approach towards a, I would say, the CQRS event sourcing approach. First disclaimer here. CQRS and event sourcing are no, I would say, catch-all patterns. You can easily go ahead and just pick out one business domain where this is essential and very suitable, and still work with the rest of the domain in the classic approach. Note one. So you can have a step-by-step approach. So you would usually go ahead and you have a very business uncritical thing which actually fits very well in there. So you can collect your experiences. You can create a proof of concept on top of that. What I would go ahead is, in these things, I would split up the read-write part. And then first of all, I would actually, it depends on the risk that you want to take. If you want to have a conservative approach, you could go ahead and use the relational storage for reads, for the event storage, and for the query part. But what I actually would do is externalize the event store. For instance, towards some Redis storage or something like that. And you might replicate into highly aggregated tables on the relational storage. Okay. Yes? Okay. Okay.
With event sourcing and CQRS, looking for sample code that I can just clone and start modifying.
Okay. The question was, what is the best starting point for event sourcing and CQRS with starting code that you could easily clone? To be honest, I can't name you a reference. I think there are some open source projects that address this, especially some CQRS frameworks. One is, yeah, exactly. And that could be a good starting point. Axon. AXON, exactly. So that would be a good starting point there. I think Martin Fowler wrote a very interesting blog on that with tons of code examples. But I think his examples are written in Scala as far as I know. A very interesting tooling is also the akka persistence thing in Scala. I hope I don't get beaten up at a Grails Groovy conference for mentioning akka persistence on Scala. I doubt that. Yeah. Okay. Yes? Okay, the question is when I'm validating in a high volume system, if the validation on the command end, if that wouldn't be a bottleneck. No, because we have a very, or I would say not in most of the cases, because I have a very I can create a very high performance read storage, which reduces my read costs significantly. And that should usually have a pretty good performance. Let me just repeat that, what you said. He just said, just go ahead and set up very simple and highly available, highly performant data buckets for these validation queries. And I've actually worked on an event sourced system where we modeled our queries as the query parameters as map keys. And it was just a distributed in-memory map or several, 80 highly distributed in-memory maps. The query parameters were just map keys. And that was like really fast stuff. Okay, there was one last question.
The read store is an in-memory database. How do you deal with like aged data? Like, can you expand on the checkpoint to the snapshot?
Okay. If the read storage is a highly distributed in-memory data store, how do I?
Deal with like aged data, so somebody
Okay.
log in.
Okay. First question is, if I have aged data, well, I can have easily read storage and read buckets, let's say from last week, last year, and so on, if I need that for my business domain. You can be very creative and very flexible in terms of the read buckets that you have. And these buckets can also then be, and he also asked if I could elaborate a little more on the concept of these snapshots and checkpoints. You can easily, for instance, go ahead and save a, let's say, read storage snapshot of 12 o'clock, 1 o'clock, 2 o'clock, and so on. And you can then go ahead and apply the new events on top of this read storage, for instance. That's the pattern. Yeah. Okay, just 2 last remarks. You can follow me on Twitter, @bitboss is my Twitter handle. And I will upload the slides of this talk to slideshare.net/mploed. And as soon as I've done that, I'll publish that on Twitter also through the S2GX hash map. And I want to thank you very, very much for the great discussions after the talk, for all of you coming to the talk and showing interest into that topic. I'll be around today at the conference, so if you have some further questions or anything else, just say hi. And yeah, thank you very much.